Simple machines are devices with few or no moving parts that are used to modify motion and force in order to perform work. Simple machines are the inclined plane, lever, wedge, wheel, axle, pulley, and screw. The inclined plane consists of a sloping surface and is used for raising heavy bodies. The plane offers mechanical advantage in that the force required to move the object up the plane is less than the weight being raised. The principle of the inclined plane is used widely, for example in ramps, switchback roads, where a small force acting for a long distance and slope can do a large amount of work. The lever provides a mechanical advantage. A mechanical advantage refers to how much a simple machine multiplies an applied force. The location of the effort, load, and fulcrum will determine the type of lever and the amount of mechanical advantage the machine has. The farther the effort is away from the fulcrum, the easier it is to move the load. Let's take a look at a few of the different levers there are. There's first class levers, there's second class levers, and there's third class levers. In the first class lever, the fulcrum is located between the load and the effort. An example of a first class lever would be a pair of scissors or a teeter-totter. Second class lever, the second class lever is the load is located between the effort and the fulcrum. Examples of a second class lever would be a wheelbarrow or a bottle opener or even an oar. Third class lever, the effort is located between the load and the fulcrum. A couple of examples of this would be a tennis racket or a baseball bat, a fishing rod. A wedge is an important object that tapers to a thin edge. Pushing the wedge in one direction creates a force in a sideways direction. It is usually made of metal or wood and is used for splitting, lifting, or tightening. In terms of mechanical function, the screw may be thought of as a wedge wrapped around a cylinder. The wheel and axle is made up of circular frame, the wheel, that revolves around a shaft or rod, the axle. In its earliest form, it's probably used for raising weights or water buckets from wells. Its principal operation is best explained by way of device with a large gear and a small gear attached to the same shaft. A pulley is a wheel that carries a flexible rope, cord, cable, chain, or belt on its rim. Pulleys are used singly or in combination to transmit energy and motion. Pulleys with grooved rims are called sheaves. In belt drive, pulleys are affixed to shafts with their axes, and the power is transmitted between the shafts by means of endless belts running over the pulleys. One or more independently rotating pulleys can be used to gain mechanical advantage, especially for lifting weights. The shafts about which the pulleys turn may affix them to the frames or blocks in a combination of pulleys, blocks, and rope, or other flexible materials referred to as block and tackle. It is said that every pulley added to one of these simple machines cuts the weight in half. The screw is usually a circular cylinder member with a continuous helical rib and is used either as a fastener or as a force and motion modifier. TPI stands for threads per inch. This is simply a count of the number of threads per inch measured along the length of the fastener. TPI is used only with American fasteners. Metric fasteners use thread pitch. In general, smaller fasteners have finer threads, so the thread count is higher. The way you measure metric fasteners are specified with a thread pitch instead of the thread count. The thread pitch is the distance between threads expressed in millimeters, along the length of the fastener. For example, the thread pitch of 1.5 means that the distance between one thread and the next is 1.5 millimeters. In general, the smaller fasteners have finer threads, so they have lower pitch threads. So you may be asking, what's the difference between a fine thread and a coarse thread? Well, bolts with a coarse thread have a larger pitch, fewer threads per inch, compared to fine threads. A coarse threaded bolt is specified by most applications unless there's an overriding reason to use a fine threaded bolt. Furthermore, fine thread fasteners are more difficult to obtain. Fine threads are more susceptible to galling than coarse threads. They need longer thread engagements, and they're more prone to damage and thread fouling. They are also less suitable to high-speed assembly since they are more likely to seize up when being tightened. Some of the potential benefits of fine threads are size. For the size of the fine thread is actually stronger than the coarse thread. It's both in tension because of the larger stress area and shear because of the larger minor diameter. Because of the smaller pitch, they allow finer adjustments in applications that need that feature. Fine threads can be more easily tapped into hard materials than thin-walled tubes. Fine threads require less torque to develop equivalent bolt preloads. Fine threads have less tendency to loosen since the thread incline is smaller. Machine screws are used to clamp machine parts together, either when one of the parts has a threaded hole or in conjunction with a nut. These screws stretch when tightened. The set screw fits into a threaded hole in one member when the tightened cup-shaped point is pressed into a mating member. Self-tapping screws form or cut mating threads by displacing material adjacent to the pilot hole so it flows around the screw. Wood screws are made up of a variety of diameters and lengths. When using larger sizes, pilot holes are drilled to avoid splitting the wood. Lag screws are large wood screws that are used to fasten heavy objects to the wood. Heads are either square or hexagonal. Let's talk about drive types for a second. That's the shape of the top of these screws. There's so many different shapes and sizes at this point that it's it's hard to figure out what you need for the purpose. But there's one thing that I want you guys to keep in mind. The more points of contact that you can find with the screw, the better your bit's going to hold up and the less chances that you're going to strip out your screw or your driver. So I'm going to say the Torx bit is probably the best bit at this point right now. Okay, this concludes my short lecture on simple machines. Again, simple machines just make work easier. Simple machines can be found all over the world in combination, creating complex machines. So it's important to get a good basis or a good foundation of just how these simple machines work.